Hello, welcome back to the electrical course here. With the course to the course we're tutoring with Abdul. In this session of the video or the lecture, we will be talking about measuring devices or instruments. Earlier, we talked about all the quantities, electrical quantities. We found the values. For instance, we found the volt. We found the resistance. We found the amperage. We found the wattage. Now in this lecture we will be talking about how to measure them by electrical equipment. We call them the meters. So everything has their own assigned meter or device that for instance volt and resistance and amp and wattage can be measured with. So we will do some practical example here. So how to use a device that measure volts, how to use a device that measure resistance, and same thing with all these four, which will be a voltage, resistance, amperage, and wattage or watt. First, we will be talking about voltmeter. As we can see from the name, it says volt, right? So it's a voltmeter. It will be measuring volts, measuring voltage. And earlier we discussed that we have two kinds of voltage, which is AC, alternating current volt, AC and DC source. So we'll have to be some of these meters that we are using, voltmeter, they're not automatically assigning, so they might have a selector switch. To flip between AC and DC, AC and DC, and some of them are automatically. It will just automatically detect if it is a sinusoidal or which is a AC or if it's DC or direct current. So voltmeter is used for measuring the electrical it's a voltage, and the voltage that is at our houses, industry, anywhere. Voltmeters can be assigned in different categories. They have a lot of categories there, but there are a variety of options. I'll be attaching some pictures of voltmeters or the digital multimeter here. So that is, it's called multimeter, I will say, because it's measuring a lot of stuff. It's measuring resistance meter, resistance meter, and even amperage. It has a limit to it, how much voltage is that can measure and how much amperage that can measure. So we will come back to that in the end of this video probably. The second part of this video will be practical work and how to measure some stuff here. Now the second one here is resistance. How to measure resistance here. To measure resistance here, so we have a device that we call it VOM or volt ohm milliamp meter. Milliamp meter. Volt ohm milliamp meter. This device is used to measure resistance in a circuit. Remember one thing here. When we measure resistance, remember power should be off. Power must be off. Power must be off of the circuit. Otherwise it will destroy the VOM meter, or we can call it like whatever you however you call it. Like I call it volt ohm milliamp meter. If you don't turn off the power of the circuit, for instance, it has a 120 volt supply and you're measuring a resistance in that circuit and the power is still on, you will destroy this device. So it'll be good practice to power off the whole machine if you're dealing with machine, or to kill the circuit breaker, or power off the circuit breaker if you are dealing at house. Disconnect that connection to the power source and then measure the resistance there. So how usually that works, for instance, if you're measuring resistance, so your one of lead 1 will be here and lead 2 will be here. So that's how you measure resistance across this particular resistor. It will tell you the value and how much of a resistance you have. We will come to the, as I said, like the second part of this video will be assigned to practical hands-on working. So in this part of video we'll be talking about just what are these equipment called. Now we have number 3, how to measure amp. To measure amp, we select amp meter. For that we can we have a different type of meters to measure the amperage, but the thing is here, the one that we have a conventional meter or from digital multimeter, what we can do if we have to measure the, for instance, this is our battery resistance, one more, and there is your, for example, 12 volt DC R1 R2. If we have to measure the amperage here, we have to connect we have to open this circuit and connect one lead of the amp meter here, and this one, the other piece of that will be connected here. So the meter should be in between here, meter, so that whatever amperage is going through the circuit, you will see it right here. Or just to draw a good picture here, same picture but in a different. Okay, now we have an opening here. Alrighty, so there is my meter. That's a good sign of meter anyway. Okay, amp meter. So R1 R2, and this is your V, which is 12 volt. So what we're saying is here, we have to, the load has to go through that amp meter. That being said, you have to make sure that your amp meter can tolerate the amperage of the circuit board, the circuit that we have. Otherwise it will destroy or burn the amp meter too, because the resistance and the tolerance of the amp meter might be different in this case. So, and that if we figure that out, and if our operation is safe to be used, then we can connect it one lead. The power should be coming from there, connect that to the power, or even you can connect it right here too, or anywhere you want to, because it's a series connection, so your amp should be the same here. And ongoing, one lead connecting to the, coming from the source, and the other one is going to the resistance. It will tell you how much amperage is going through that circuit. And we do have a lot of different kind of it, but if you are dealing with for example, for 3 phases, 480 volts, that's a good practice to use. A lot of electricians use a clamp on meter, clamp on amp meter. This is a meter that has a jaw, and you can just put it in a single phase of motor lead or a load to see how much amperage is that particular device drawing. So clamp on meter, it's rated for different voltages, so different amperage. Make sure that is assigned for the particular job, otherwise that's dangerous to use it. So that's clamp on meter. I use this a lot, and it has a very safe and successful operation. It's very precise. It's made of some with some shunts, electric shunts like shunts. So we will be not talking about that. What is it made of? We will be talking how to use it in this course. So yes, clamp on meter, amp meter will be the best option if somebody is working in industry setting. So to measure if you are measuring 3 phases, for example, this is your control relay, and you have 3 lead, line 1, line 2, line 3, and you have 3 screws right here, and 3 wires are going out. It'll be usually brown, orange, yellow. It says boy. So you put your clamp on meter here. I can't draw, I'm not a very good drawing. So clamp on meter on this wire, and whatever amperage is reading, it will tell you in the meter right here. For example, it's 3 amp. And same thing you have to do with this one too. So that's how we check the amperage on a circuit. Okay, now moving on to the part of what is that? The third one is wattage. Fourth one is wattmeter. Wattmeter is used to measure power in the circuit. Okay, so I didn't say amp meter is used to measure current in the circuit. Okay, back to wattmeter. Wattmeter is used to measure power in the circuit, and the unit of power is watts. Watt is the unit of power. So how we use this one? Since power is the product of voltage and amperage, so that means we have to use 2 different settings. For instance, if we are measuring this, this should be small, this should be big, because plus is that. Okay, so how we measure power here? So first of all, you have to measure the current. So one lead is going from here, and this is your meter. This is your amp meter. Okay. Now the second one is your load voltage. You can put your one lead here, other meter, and the other lead right here. So if you get for instance, it's 12 volt battery here. If you get a 3 amp here, and you get, like for instance, 5 volts here. So that's how we assign. That's how we have to put, because it's a power. To measure power, you have to have two components or 2 measurement here, amperage and the voltage. So to measure amperage, you have to be connected in a series with a circuit, and you have to be, and to measure power, voltage, you connect it to the load side of it, So you can either do it right here, measure the load of this load of the circuit, load voltage. Okay, so this will be, for example, it's coming right here. So it's from beginning to the top. The load voltage is, for example, 12 volt. We know that 12 times 3 is the power here will be 12 times 3 is 36 watts. Just an example. This is just, it's how we measure wattage here. Okay, so let's keep moving here. Okay, so we have quite a few more, couple more measurement to be made. Okay, we talked about voltmeter. Voltmeter can measure voltage when a circuit is stable, when it's on for a certain amount of time, and it's we just plug in the leads. A voltmeter has two leads, plus and minus, or hot and neutral, negative lead. So we plug in that in respective places, and then we will have a reading. But what if I have a pulse? Pulse is a electric pulse is a voltage that is on for a certain amount of time, for example 3 milliseconds. How we measure that with voltmeter? Our voltmeter is useless there. It will not work. A voltmeter cannot measure the limited time signal or pulses, because 3 milliseconds is just like it's too quick. The voltmeter brain memory is not that quick to catch that thing. For that we use a device, we call it oscilloscope. It is actually, it's a voltmeter. It measures voltage in a short time, in a short period of time. Okay, so that, what does that mean? For example, if there's if a switch is coming on and off, and so in my bad, oscilloscope will give me 2D picture, two-dimensional picture, which is this guy right here. So it will measure, this is for example 1 millisecond. How can we measure this voltage of this particular voltage with voltmeter? There is no way we can do it, but we can measure this with using oscilloscope. It will give me the timing and the peak point, and that's how we get our reading there, if that's a DC connection. But if we have AC, it will be like somewhere like there. So it's either way, it gives us like a two-dimensional picture in oscilloscope. That's a good thing about it, because it's a very convenient when we're dealing with the small pulses, the short pulses. We use oscilloscope, but it is mainly used to measure voltage in a short period of time. Speaking of measurement, we can go ahead and see, like, okay, how we measure frequency. What is a frequency? Frequency is defined 1 divided by time that takes to complete a cycle. 1 divided by time something completes a cycle. So what does that mean? Complete cycle. So it's over 1 over t. That is defined as a frequency. F is frequency, t is time, capital T is a period time. So 1 divided by the time that something completes a cycle, it's defined as a frequency. There is no electrical measurement for there is no electrical component to measure that thing other than this oscilloscope. We can use that to find that timing, and this is how we find the time, and we will find the complete cycle. For example, if you take like as an example, if a pulse takes 3 milliseconds to complete a cycle, what is the frequency? Frequency is measured in hertz, Hz. So how we, by definition here, we said F is equal to, frequency is equal to 1 over T. So F is equal to, we said like T was a 3 millisecond. So 1 millisecond is equal to 10 to the negative 3 seconds. Correct? That will be 0.003. That's 3 millisecond. So it'll be, if it was 1, it will be 0.001. Now 1 divided by 0.003, 1 divided by 0.003 will give me 333 hertz. 333.33, this is repeated, but I'll say like 333.3 hertz. That's how we measure that. We have to get the data from the oscilloscope of the completing cycle, then we can just do some math and find the frequency from there. Okay, so that was the frequency, how we measure frequency here. And normal frequency in the US, frequency in the US is 60 hertz. So that's something to remember. Alright, moving on to one of the big thing that we use in industry, which is Megohmmeter. Or Megger. We call it Megger in a simpler language here. What is Megger? Megger is a device that measures resistance, but very high resistance. It is usually used when we're installing some equipment. In industries, for instance, we're running 3 phases, 2 phases of 1 phase, or any insulation that you're running. We check it with Megohmmeter or Megger to see if it is shorted in between the lines or if it is grounded to the lines. So there are 2 uses for Megger. One, for short between lines. 2, for grounded circuit. Ground circuit. So that, what does that mean? For example, if you're running into 3-phase motor that run 480 volts, so each phase should be independent of each. But if for some reason motor is acting up and the sinusoidal, this is your sinusoidal signal. If, for example, if it's going like crazily like that, it's making a noise or it's burning, it's getting hot, there will be good indication to open the lead of the motor, kill the power, and connect your Megger to each lead. You have only 2 lead, plus and negative. Connect that to one lead and this one to the other one, and read the resistance. There is a tester button usually on a Megger. Press that. See, what are you reading? If it is low resistance, then that means it's short between the lines. If it is a very high resistance, the measure is usually assigned a value, how much it go higherly, the higher resistance of the measure. So if it reads high, that's okay. If it reads really low, then that's short somewhere. And you do that with all these three phases. If it is three-phase motor, if it's line connections, you can use it anywhere to check for the short and ground. The ground is when you suspect the connection, the line is actually not touching the other line, but it's touching the ground. It's tripping the breaker, for instance, or blowing the fuse. That means your current, like 480 volt, going into supply. You have three wires there. Three wires going into motor. That's not motor. So this is a motor. This is a motor, for example. This is your, okay, so that's your junction box for the connections here. For the motor connected coming in the power right here. If you see this, when you turn on this, if this motor is for anything, for example, is a conveyor motor or is an elevator motor, anything, as soon as you hit the start button, it tripped the breaker. So the one thing will be to check see how the physical condition of the motor is, to see like if it is hot, it's burning, it's smelling something, so that will tell you like, hey, the motor is going bad. But if the motor is not getting hot, or something is not, still be getting hot, but see, hey, it's in a representable condition, then you open this box and measure meg the motor. Use the Megohmmeter or Megger to meg the motor. Have to check all these three phases, this to that, to see if you're reading okay. If you're reading okay, then you must have a power source issue right here coming from the main panel. So that's how we use the megger to measure the short and grounded circuit. For the short, we check in between lines. For the ground, we check every line to the ground to see like, hey, if the ground is actually somewhere is connected, or somewhere insulation from the lines is being burned out and is making contact with the ground. The ground can be the conduit coming from the main panel, or a raceway, anything. You have to check it all the way to there. So the recap will be, we talked about a voltmeter, ammeter, VOM or volt ohm, milliammeter, and megger. We talked about oscilloscope too, and in the end we talked about megger, how to use a megger too. So this will be it for the theory of this part. In part 2, I'll show you how these ammeter, voltmeter, and megger and oscilloscope looks like. Please go ahead and read your chapter, and chapters for measuring electrical devices, like how to measure voltage, resistance, wattage, and amperage. In this upcoming video lecture, we'll be talking about a practical circuit, how to build it, and how to measure it using these electrical equipment we said.